Hey guys, Fro here. Welcome to this lecture. In today's video, we're going to be talking about neural networks. You might have heard about artificial intelligence, you might have heard about neural networks, but have no idea what it is or why it's important in the first place. So my goal in this video is to break it down and explain what is a neural network and why exactly is this very important. So this is not going to be a very technical video, so for non-technical folks, you should be able to follow up and understand what exactly is going on. This is a primer, it's an introductory video for anyone that just wants to understand what a neural network is. So we're going to get started in explaining this with a scenario. So think about, say you're trying to buy a house. You live in a neighborhood and you're trying to buy a new house in that neighborhood. And what you want to understand is tell what the price of this house would be. So I'm gonna use this in blue. So what we want to figure out is what the price of this house would be. Now, if you want to predict a price for a house, which is what machines are good at, they're good at predicting stuff. If you want to predict what this price for the house would be, we can start thinking about what are some of the inputs that would affect the price for this house. So what are some of the variables, what are some of the things that would affect a price if you're trying to buy a house? I can come up with three. We can say, well, the price of this house can be affected by, I'm going to start here, it can be affected by the neighborhood. So I'm going to use neighborhood as NH. So NH means neighborhood. So depending on the neighborhood or the area where this house is going to affect the price of that house. Another thing that can potentially affect the price of this house could be the interest rate. So depending on what interest rate of the market is, the interest rate goes up and down. Depending on what the current interest rate of the market is, it can also affect the price of this house. So that's one thing that we can take into consideration. One other thing that could affect the price of this house, in addition to the neighborhood, is an idea of the school district. So what school district this house is in would affect the price of this house you're trying to buy. So these are a lot of things that can affect the price of this house. And as you can see, there could be more things that I can add here in order to determine what the price of this house we're trying to buy would be. Let me make it look more interesting. All right. So now, we say this and this and this affects the price of this house. But something interesting comes up. And that question is, well, let's do this. Let's make this, so this plus that plus that. All right. So something interesting comes up. And that question is, assuming that you can tell me the neighborhood and tell me what the interest rate is and tell me what the school district is, I can tell you I can predict to you the price of the house. So what we've done here, and I'm going to use a different color for this, is we've built a model. This formula that we built is basically what the model would be. This is just a linear model because you give me any input, I can predict to you, I can tell you what the output will be. So if you've heard about linear models, and then there are logistical models which I wouldn't even get into in this video, but just take this as a basic model. A model is something that you can put in a bunch of input and you can predict an output. So in this scenario, we've taken a bunch of inputs and now we're able to predict the price of the house as an output. In machine learning or in artificial intelligence, the correct terms here would be, these are the features, these are the input features, and then this is the output label. So I'll just put it here as features. So whatever goes into this left side of this equation is my feature. Whatever goes to the right side, what is being predicted, is my label. So typically you're predicting one label. So my features are these variables that go into the left side, and then what I'm predicting on the right side is my label, which is in this case is price. But I'm sure some of the smart ones out there watching this will say, but I see a problem with that equation. Maybe the neighborhood has more impact on the price of the house than the school district, or than what the interest rate will be, or maybe the interest rate has more impact on determining the price of the house than this other two. So there are different impacts that any one of these features, any one of these labels can have on the price of the house. And we have to take that into consideration in order to make this equation a little bit more clear. So what we do here is we introduce what they call weight. So each of these features is going to have its own weight. So in this case, we're going to give a weight to this. So let's say, and I'll represent weight as W. So W1. So this new equation will be W1 times the neighborhood, W2 times the interest rate, and W3 times the price gives us should give us the price of the house. So W3 times the school district gives us the price of the house. Now, this new equation that we've just put out here could be a little bit more predictive than what we had before, because we didn't take into account the fact that this weight could be higher than this weight, and so it has an impact in terms of predicting the price of the house. But what we've done here is very manual. We've gone through the steps of trying to identify. First, we've identified the features that are important to predict the price of the house. We've introduced the idea of weight into the price of the house, and then we have a model. And I'm going to write it here as, let me use green. So this is a linear model. So what we've done here is a linear model, and we can test it out. We can test it out with numbers. So we can say, assuming that we had a data set of NH, IRA, IRO, and ST. So let's say NH was 2, this was 3, and this was 5. Right, so we just give it figures, right, just numbers. You can always replace this with actual values, what the interest rate is and that, but I'll just use numbers here as an example. So given this set of input, I can tell you what the price of this house would be by simply plugging it into this equation. So to do that, we also need to understand what the weights are. We can say weights here, weight 1 is 2, weight 2 is 1, weight 3 is maybe 3. So let's use the full weight. Now, given the idea of our weights, we know what the weights are. We can now calculate what the price of the house will be. So we can say, to calculate the price of this house, we just need weight 1, which is 2 times 2 plus 1 times 3. So there's really no impact here. Plus, in this case, now we have 3 times 5 equals to, it can tell us the price of the house. And if we do the math, here we have 4 plus 3, that is 7, plus 15, so that is 22. So the price of our house will be 22. So if somebody gives me a house and they want me to give me some data and I want to predict the price for the house, I just need to grab all that data, plug it in here, and I can predict the price for the house. So this is what has been always done in the past, and I'm going to clean things up here a little bit. So this is what has been done in the past. I'll add one more term here of features and labels. So given any house, given any set of inputs, we can predict the price of the house using a linear model. There are more types of models we can use, and we can get really complicated with what that equation looks like. But again, just keeping this very basic with the understanding that this is just a very basic model to prove the point. Now, what is a neural network, and how is it important in this equation that we have here? So the number one challenge that we have here is, first, we have to understand these features. We have to identify what these features are. And in data science or in machine learning, that process of figuring out what these features are is called feature selection. It's called feature selection. So we're trying to select the features that will be used. Because you can ask, but now we have just 3 features here. What about the color of the house? Does the color of the house have an effect on the price? If so, we should include it here. Or maybe what about the square footage of the house? Maybe that's a very bigger predictor to the price of the house than the school district or anything else. We should include that into our equation. So there are a lot of other features that could potentially be affecting the price of the house, but by using this manual approach of just putting things and guessing, we might miss those very important features and not have it included in here. So that's the shortcoming of this approach of the linear model, because it's very manual, it's very time consuming, it's very intensive. Some of the things that you can see this in the real world is you're trying to build a model that can take an image and predict if the image is a dog or a cat, right? What features do you go after? Do you go after nose? Well, a dog has a nose and a cat has a nose. Do you go after eyes? They both have eyes. So what features would differentiate a dog and a cat? And so when you start getting into those complicated scenarios, building a model like this by hand just does not work. It's not possible. And that's where neural networks come into play, because what neural networks are great at is feature selection. So what the neural network does really well is being able to select features. And how did they do it? They use the same idea of what we've done here, of weight and a feature and creating the equation. But the difference with the neural network is they can deduce what features are important to you automatically. And there are two concepts that come into play. Number one is called forward propagation. And then, so that's forward propagation, and then there's also, of course, backward propagation. So using a combination of forward propagation and backward propagation, a neural network can guess what features are important to predicting the price of the house and what weights are available, should be used or should be applied to those features. So instead of us manually guessing what weights or what features should be included, what a neural network would do is it can guess it for us using forward propagation, where it just comes up with a random set of features and it tests if these are the features that should be used in that prediction. And if there are errors, the backward propagation figures out what those errors is, and then it minimizes those errors by using what they call gradient descent. So it minimizes those errors by using gradient descent. So the whole idea for a neural network is really solving this problem and making it very automatic. So you can take something you're trying to achieve. Say you're trying to find the difference between given two images to tell whether one is a dog or one is a cat. By using a neural network, and I should write it here. So by using a neural network, we can simply feed in those two images and let the neural network tell us that these are the features that are important, these are the weights that are important to that feature, and it can deduce that for us all automatically without us having to fiddle with equations like this. Even with the housing prices, instead of us having to try to figure this out manually and adding color and adding square footage and adding, what the roof looks like, there could be hundreds or thousands of features here, but we don't know which one exactly and how much, which is the weight, affects the price of that house. But the neural network can take in all that data and it can deduce that for us using forward propagation, backward propagation, and gradient descent, which is a way of figuring out what weights affect the price of the house. So in the next video, I'm going to dive more into the neural network and explain what it is. The things that we're going to be talking about in that video are the three components of a neural network, which is your inputs, your deep layers, and then your output. So there are really three areas. Your input layer, which is just basically the list of features that exist. So it takes all the features and it lists them out. So this will be your input layer. So if I had 1, 2, 3 features or 10 features, I shouldn't be eliminating features. I put all my features in here, and then the neural network can then analyze to tell me which features are important. So using this, which is your input layer, your deep layer, and you can have multiple layers here, and your output layer, which is where the prediction happens. So it can tell me which of these features should be important in the prediction that I'm looking to do. and it comes up with this equation for us, which will be more precise for us. So guys, I hope this gives us a soft introduction to neural network. If you've ever heard about it and don't understand why it's even important in the first place, this is why it's important in the first place. If there's one thing you want to take away from this video, is the fact that deducing equations like this in linear models is very, very time consuming and expensive. We need a better way to do it. And what the neural network does is it gives us a way to do all of that automatically by forward propagation, back propagation, and gradient descent. My next video will dive into talking more about the neural network. But if you have any questions based on what I've explained here, guys, please leave that in the comment below, and I'll see you in the next video.